It's looking good. Oh man. Oh man. We are basically in the middle of nowhere, which is actually far, far north. We're roughly at the polar circle, and we're here in Sweden, close to Kiruna, at the S-Range Space Center.
On S-Range we launch sounding rockets, stratospheric balloons from small to big sizes, and very soon also from next year satellite launches. S-Range was actually founded here at this place because it is above the polar circle and we have quite often the northern lights, the aurora borealis. And everything started basically with the research on the aurora borealis when the scientists came up here and wanted to investigate on them.
Actually, historically wise, we've been building space watches since a couple of decades actually. And literally we came up with the plan to bring back the space tested watch to planet Earth, which means to have a space tested movement. So it's not a watch that we want to send up there by accident and it's going to work. What we want to find out is that movement working in space? So that's why we're testing it. Therefore, we are now kind of collaborating with a new company to create a manufacture caliber. It's a column wheel chronograph. We call it Werk 17. And that's the caliber actually we're going to send up to 30 kilometers to test whether it's going to resist in space or not.
So on the upper part we have basically the gondola structure which will carry the watches. So these arms here will basically provide the mounting brackets for the watches themselves. And in the lower part there we have a bit thermally insulated the box for the electronics,
okay,
and the measurement system.
So all the data is collected in here?
The data is collected in there, the temperature and pressure data is collected in there, and so through this cable we basically have the connection to the upper part, and then the different watch heads which are measuring right now, they will be then added with temperature sensors, and the temperature sensors or the temperature data is basically recorded down in there.
Im Prinzip aus der Theorie haben wir in Grenchen das Uhrwerk so entwickelt. Dann hast du Laborprüfungen gemacht in Grenchen, hast dir das in ein externes Labor auch gegeben und nicht intern, wo du dann alles nochmal durchgeprüft hast, ob es stimmt, was wir uns da ausgedacht haben. Und jetzt kommt der Praxistest. So, jetzt musst du natürlich vor dem Abflug schon schauen, dass das alles so war, wie es das Haus verlassen hat. Und nach dem Ballonflug machen wir genau das Gleiche nochmal. Und dann sehen wir die Abweichung oder ob es überhaupt eine Abweichung gegeben hat.
So basically we've mounted 13 movements on a gondola, which is hanging below or beneath a balloon that's filled up with a helium gas. And then the whole gondola system will be carried out into the sky and way beyond that actually. So you're leaving basically the atmosphere and you're entering stratosphere.
We will pass on the way quite low temperature regions so up to or down to minus 50, 60 degrees. We are definitely in the conditions very close to space. So you still have like a rest density, a residual density of air, but it is very, very low. So you're almost at vacuum, so very low pressure. You have a similar thermal behavior because you have the direct sunlight, the radiation of the sunlight.
We want to do space-tested watches. We're not just doing some kind of watch and put it into space and see what's going to happen. So you really have to be in control of what your movement is capable of, taking. This is not like, oh, do we need this oil or that oil, or is it about the right glass or everything? At the end of the day, is the watch coming back safely, and is it still accurate? And I think that's the main point. We're doing it for people who travel that in the future, who go for space tourism like Virgin Galactic and they'll.
Wenn du auf den Mars fliegst, solltest du vorher wissen, ob alles funktioniert. Der Trial and Error funktioniert nicht. Und jetzt im SSC haben wir eigentlich einen super Partner gefunden, der mit uns zusammen mal eine Weltraumnorm entwickelt. Und auch die Überlegung, wie kann ich in Grenchen ein Labor installieren, damit wir in Grenchen auch direkt Weltraum simulieren können.
It is always difficult to build something which has to survive under space conditions. So those conditions are so special. We have vacuum conditions, we have high temperatures, low temperatures, very low temperatures, we have radiation. So everything has to be designed in a way that it will withstand those conditions and for a long time. So everything around the infrastructure which you need to provide to test these watches in space need to withstand the environment as well. So it is a challenge. It is quite interesting for me as an engineer as well to see basically the technical side. So seeing like a mechanical movement of a watch in space and see what is happening there due to the environment, which is very special. This is something what you don't usually have down here. Vacuum, special temperature conditions, radiation. So that's for me as an engineer also interesting to see, even though I'm usually working with more in-depth science experiments.
Alle ready?
Okay. 3, 2, 1, 0.
Famous last words.
Last words. You ready?
Flieg nicht so hoch, mein kleiner Freund.
Släpp sakta.
Okay.
Good luck. Lycka till.
Låt den glida den där.
4,
Efter handen.
3, 2, 1, launch. Das Ding steigt ganz schön, hä?
water. Oh, there it is, yeah. Yeah.
It's looking good. Oh man. Oh man. So
everything seems to be synchronized.
the chronograph, I'm going through them one by one. So this one's working. Oh, that one actually stopped. That one's working. Working, that's the good one. Working. Working. Properly working. Check. I can't see the outside, so yeah. Yeah, cool. So basically it's not about if the movements do work right now properly. It's about when we bring them now back and test the accuracy. It's about, are they getting back to that same accuracy which they had when we put them on the gondola. So because it's like on a rocket launch, the vibration and all of that is not good for a movement at all. So you will have maybe some disturbance there, but if it's getting back to regular after a certain period of time, you're actually back on track. So that's, can it withstand the forces and getting back on track then. So that's basically what we did here. Thank you, thank you. So I think mission accomplished, isn't it? Awesome.
It seems that everything survived until now. So, and the gondola is still, even that we had to cut down the tree, in a very good condition, and now it's just checking for the data later.
Excited for the data we get.
Yeah. Congratulations. Back on Earth. Back on Earth, yeah.
Also grundsätzlich sind wir sehr zufrieden mit den Ergebnissen. Ist eigentlich genau das rausgekommen, was wir auch erwartet haben. Uhrwerke laufen alle noch einwandfrei. Bei 1, 2, da ist nicht das rausgekommen, was wir erwartet haben, aber eigentlich grundsätzlich absolut zufriedenstellend. Richtiges Ergebnis können wir jetzt noch nicht mitteilen, weil wir müssen jetzt erst zu Hause die ganzen Uhrwerke demontieren, alle Teile einzeln anschauen, alles nochmal nachmessen und dann werden wir, sage ich mal, 3, 4 Wochen werden wir effektive Ergebnisse haben. Also nächster Schritt ist, dass wir nächstes Jahr in einer Rakete dabei sind. Dieses Jahr war es jetzt der Ballon. Nächstes Jahr werden wir in einer Rakete wirklich bis ins Weltall fliegen. Und dann, Ideen haben wir schon für die nächsten Schritte, werde ich aber noch nicht verraten.
actually.